Welcome back, everybody, to the lecture 2 about types and classes. And in this part, we're going to talk about types of functions. And since we are dealing with functional programming, functions, values, and types are very important. And since this can be a little bit difficult for beginners, please pay attention to this lecture in particular, because if you miss this, you will have difficulties in all the remaining lectures. So I will go a little bit slow here and repeat many times, because this is super important that you understand this part. What is a function? A function is a mapping from values of one type to values of another type. So here are two very simple examples of function types. The first one is the function not, negation, which takes a Boolean and returns another Boolean. Nothing too complicated. Let's look at the second function here, isDigit. IsDigit takes a character and checks whether that character is a digit, so whether that character is 0, 1, up to 9. The type of that is char to bool. So what that means is it takes a value in the set of all characters and will return a value in the set of Booleans. And in general, a function from T1 to T2 is, the type T1 arrow T2 is the type of functions that map values from type T1 to values of type T2. T1 is also sometimes called the domain of the function, and T2 is sometimes called the range of the function. Now you notice that we write the arrow of the function type as a nice arrow, but when you use the keyboard to type in the actual code, you will type that as a dash followed by a greater than sign. So, but we will use the kind of nicer syntax here, but just be careful. This is not, how you type in actually the arrow. When you have a function, just like with tuples and with lists, the types for the range and the domain are unrestricted. For example, we can have a function here, add, that takes as the argument a tuple of 2 integers and returns as a result another integer. So add of x comma y equals x plus y. So you see here that add takes a tuple of 2 integers and returns a result that is an integer. And the other function here is a function that takes an int and returns a list of integers. And perfectly fine. And the definition there, 0 to n, returns the list 0 ... n. And we have seen in the very first lecture that this square bracket with the double dots denotes the list from 0 up to n. One thing, if we make the types, the arguments and the results of function types arbitrary, they can be functions themselves. And this is where curried functions come in. So instead of defining add to take a tuple of integers and return an integer, in Haskell it's more common to define add as follows. We define add as a function that takes an integer and returns a function that takes another integer and returns an integer. So look at this type here. So add is a function, here, we see that from this arrow, that takes an integer and returns a function that takes another integer and returns an integer. So that is currying. Now, by itself, currying is not very complicated. If functions are just values like list and integer, so there's nothing special about this. The thing where it becomes confusing is that in Haskell you don't have to write these arrows here, all right? Because this is so common the arrow associates to the right, and which means that you can write this type as int, arrow, int, arrow, int. And that's where it becomes confusing for beginners. So you have to really kind of, when you read these types, know where to put the parentheses. But for now, there's nothing special here. Add is a function that takes an integer and returns another function that takes an integer and then returns an integer. Okay? Now, notice that both add and add prime return the same result. Okay? But add takes the normal add takes a tuple, so it takes both arguments at the same time, whereas add prime takes the arguments one by one. And arguments functions that take their arguments one by one are called curried functions. And the person that invented this way of dealing with functions, where the functions take the arguments one by one, was Haskell B. Curry, and Haskell is named after him. So that's where Haskell comes from, just like Pascal was named after Blaise Pascal. Haskell is named after Haskell B. Curry, the person that invented currying of functions. Every function that takes two arguments can be turned into a function that takes these arguments one by one. For example, here's a function mult that takes three parameters, x, y, and z, and multiplies them. So mult x, y, z is x times y times z. One way to write this function would be to take a tuple of three values, x, y, and z, and then multiply them. But the Haskell way of doing this is to take these arguments one by one. So mult x returns a function that takes another argument, y, and then it returns a function that takes another argument, z, and then when you have all these three arguments, you can multiply them to return the final int. Okay? So mult takes an integer, returns a function, mult x, that takes an integer y, that returns a new function, mult xy, that takes an integer z, and returns the result x, y, and z. Now what we see here is that in the type, we still write the parentheses. So the parentheses in the type go left to right. So the function arrow binds to the right. But when we write here, I have to kind of go here. When we write mult xy, we don't put parens. If we would put the parens there, we would write mult x parens, and then parens around that. So there the parentheses associate to the left. Okay, so for application, the parentheses associate to the left. For the function arrow, they associate to the right. And that matches up perfectly. So then, in practice, we don't have to write any parentheses. Now you can ask yourself, why is this currying useful? Okay, why are we just like in other languages, why don't we just have functions that take a whole list of parameters, or like a tuple of parameters to be precise, in one go? Why do we do this complicated thing of kind of taking one argument and then returning a function that takes the other parameter, etc.? Well, the reason is that we can partially apply a function. For example, if we have this function add prime that was defined in a curried way, we can define a function that increments a value with 1 by partially applying add prime to 1. So if we look at the type there, add prime 1 is a function that takes an integer and returns another integer. When we will talk about list in a future lecture, we will see that there's many functions that transform lists into other lists, and most of these functions are also defined in a curried form. For example, the function take here, take 5, take is defined as a curried function that takes an integer, returns a function from list to lists, which means that we can partially apply take to 5 to yield a function that takes a list of integers to another list of integers, which just takes the first 5 elements of the input list. Similarly, the function drop takes an integer and returns a function from list to list. And what we see here is that we can now define drop 5. We can partially apply drop to 5, and it will return a function that will take a list, drop the first 5 elements, and then return the list. So this is super convenient. It's in Haskell, it's very lightweight. So the syntax in Haskell is optimized to have curried functions. And in that respect, Haskell is very, very different from most other languages that are optimized for functions that take tuples of arguments. I already mentioned a couple of times the way we do the parentheses on expressions with function parameters. So the arrow associates to the right. So if we have the type on the bottom here, so the type here, int, arrow, int, arrow, int, arrow, int, the parentheses are associated to the right. Since we don't like to write parentheses, we can write this thing as int, arrow, int, arrow, int, arrow, int. Okay? But if we put all the parentheses in there, we get the term here at the bottom. But this is what we can write because we don't want to write unnecessary parentheses. And as I said also, when we do function application, the parentheses associate to the left. So when we partially apply a function, you can write parentheses around that, but we don't have to. So when you write mult x, y, z, that really means mult x applied to y applied to z. Okay? But unless you're using explicit tuples, all functions in Haskell are normally defined in curried form. And most languages, all functions are defined in the uncurried form. So this is the part 2 about functions. There will be a lot of exercises to drill this idea of where to put the parentheses in the function type and where to put the parentheses in the expressions. So this becomes second nature. This is something you really have to kind of keep doing until you don't think about it anymore. All right? So please do your exercises and see you later in the last part of chapter 2.